So let me introduce myself. I'm Helen Walker. I'm not a radio amateur, sorry. But I'm the UKube-1 mission manager. And so I hope you had a talk last year from Steve telling you all about the technology. And I'm going to give you work in progress and where we got to. And of course, you're all very interested because you're going to get it when I've finished with it. Sorry about that. So I thought perhaps you might be interested. How do you get to be a mission manager? You know, we're talking about outreach, STEM, and all the rest of it. It's not a job opportunity I'd thought of applying for. I have applied to be an astronaut. I didn't get very far. I was selected. Helen Sharman beat me. But I fiddle with buttons. And that is not what they want on Mir. Just a quick summary of what UKube-1 is for those who might have missed Steve last year. And I thought it might be interesting for you to think about what is a ground station, because you're going to take over. What actually are you going to take over? And what is it not? What do I do? And where are we now? It looks as though as long as I use it fairly frequently, we're okay. So this is where I started, 1983, IRAS, the first infrared astronomy satellite, joint American-Dutch-British project, and we actually ran IRAS from Rutherford Appleton Laboratory. And this is why the artist's impression shows the satellite over the UK. Not often seen satellites floating over the UK. Hopefully we'll get one of the ISS with Tim as well over the UK and not over Europe. Kieran, can we have one with him over the UK? But you can see the size of IRAS. This is the person in the clean room. It's about the size of a minibus. And this was it. We were actually, we loaned this 12-metre S-band antenna by NASA. We've still got it. Don't want it. They haven't had to strip that. And we also had the control rack to operate it. And this was actually the Apollo 16 flight spare. And I'll tell you, there are row buttons there, and they're labelled LM and CM for Lunar Module and Command Module. We never reassigned them. We just left them there. But we used that to control it. And I came down to Rutherford Appleton Laboratory as Queen Mary College postgraduate. And I came down as one of those nasty scientists, astronomers, who were going to use the satellite. And I left it, having had an interesting year. Poacher turned gamekeeper. I was fascinated by the operations, and I was starting to say, you can't do that, you know, that'll ruin the batteries. And ever since then, I've been sort of mixing and getting more and more into the operation side of it. And after IRAS, I moved on to the Infrared Space Observatory, which was the European infrared satellite. And there I was helping plan the actual observing modes and how we would commission the instrument. And after that I moved on to Mars Express and Cluster, both helping with the science planning for it. And so I get all these mad scientists feeding in what they wanted to do, and me trying to fit it all into a plan and get the maximum science out without destroying the satellite, which was sometimes a challenge. And now I'm working partly on the James Webb Space Telescope. We're actually part of the mid-infrared instrument, which is the European one of the European contributions. And this is some of my colleagues in the clean room at Rutherford Appleton Laboratory, having received bits of MIRI from 35 different institutes all across Europe. It has been put together, and there's nothing left over. And it all and it all fitted. It all fitted perfectly. And of course, every bit was tested before it came to us, and we tested it when we got it, put it together, and tested it. And after that, we actually had it in our vacuum chamber at Rutherford Appleton Laboratory, and so it was running for about 100 days at 40 degrees above absolute zero in a vacuum in this shell. This is it coming out after the test. And I was the test team lead on that, and so I was organising 3 people per shift, 3 shifts per day, 24 hours a day, 7 days a week for 100 days. And we had everything from professors to postgraduates, scientists, engineers, even sort of managers coming in to take a shift. And they all turned up. And we had one minor crisis when there was a fire in the tunnel. And so we actually had people flying in from Ireland, which avoided that issue. And so it all went very well. And this is some of the teams that we had. This is our principal investigator, Gillian Wright from Edinburgh, and the project scientist and project manager from Astrium. These are some of the crews on shift handover. Up in the top corner, there's Thedori, who's Greek, Serene, who's Lebanese and works in France, Adrian, who's Swiss, Rafa, who's Colombian and now works in Holland. Getting permission for the Colombian and a Lebanese student to come into Rutherford was a right nightmare, but we did it. We've also got Royman, who's Spanish, and Pierre, who's French, so it was a very mixed bag of people, and a lot of those people are still helping now that the instrument's being delivered to NASA, and we go over to Goddard Space Flight Center and do the testing there. But this was just like operations. You have a satellite, you have your instrument in a vacuum chamber, and you test everything you're going to do in space on the ground. And then anything that doesn't work, you can sort it out now. And it's the same that we go in to Goddard, and it will be the same all the way through. But this is the other end. You know, Miri is the size of a coffee table. You know what a 3-unit CubeSat is. But this is mine. And of course, it's in orbit. Got launched 8th of July last year. Orbit around 630 kilometres, speed 7.5 kilometres per second. And it has 6 payloads on it, and I think this is the difference. This is a technology demonstrator. The idea is that we have 6 payloads, all of which have different requirements, all of which have different demands. Little camera from the Open University, Top Cat atmospheric experiment from Bath, and of course FunCube, and a little S-band transmitter from the Cape Peninsula University of Technology. So they're very different. And my job as mission manager is to sort of plan the competing demands and pay. And originally I was saying we will not have any payloads on during eclipses. I'm now quite happy with the experience of a year of UKube-1. I'd be quite happy to run 2 experiments through an eclipse. Power, we've got plenty of power. We've got other sorts of problems, but we have power. And this was a meeting we held before launch, and this shows you the variety of people involved in it. And that's the 12-metre dish at the back, I think, yeah. So we've got Steve, you recognise on the far left, the senior engineer at Clyde Space. Mark McCrum, the technical director at Bright Ascension, who wrote a lot of the software. You might well recognise a couple of renegades at the back here. They came along, and there's representatives from all the various instrument payload teams, and there's another one there. He was here yesterday, I gather. He was representing the UK Space Agency at that point. So we had a very varied team of people, including some managers as well, but we won't go into that. And when I got involved very late on. The first time I met UKube-1, it was complete. It was being tested. And so I went up to Clyde Space and we helped conduct the operations rehearsals. And we did all the tests. Again, it was just like Miri. We tried to do as many of the tests in the lab that we would do in space. Rather to my surprise, the Flight Readiness Review insisted that we test the solar panel and antenna deployment. They were a bit worried about these burn wires really burning through, and so this is them in the clean room at Clyde Space deploying the solar panels. You can see the first panels come out, and Steve is trying to remember how much delay he put in. And so everybody's sitting there waiting for the panel to come out. And we also deployed the antenna as well. So we knew that worked. So then, of course, you put another completely new wire in and hope it works just as well in orbit. And it did. So where are we? After launch, we found it was in the correct orbit. The solar panels and antenna deployed. Some concern about one of the antenna. I think one of the AMSAT antenna. I'll come back to that later. Batteries are in very good shape. Slow spin state, and it is still working after 1 year. So at the very beginning there were a lot of problems, and I was very, very grateful to AMSAT for all their help, because of course you proved to me that it was up there and it was working, and okay, I couldn't communicate with it, but you could, and so we knew everything was okay, and we gradually, sort of with your help, I managed to sort of gain control over it. So in the end, first of all, I sort of proved that even I could uplink and downlink. We had the large data transfer. If we want to downlink data, it all gets packed up into these large data transfer, which take less than 2 minutes on the whole to get down. So they're quite an efficient way. And also, I can use this to uplink new software, which I have done. We tested the various downlink rates, and you checked out the redundant communications unit, and I think you managed to do a bit of commissioning on it over Christmas. And we checked and commissioned the payloads, but not the S-band antenna. And we've now operated and delivered data to the teams for all the payloads except the S-band, which I still haven't actually dared use. And of course we had two problems. These are a matter of public record that the UV-TRX, once we start downlink, I can no longer send up any commands. It just won't listen. And the other is the computer, the onboard resets. And these are a right pain. And as far as I can tell, UKube-1 has spent the last year either in orbit 0 or in orbit 1. And the problem is, at any time, even as soon as it's done one reset, it can decide to do another reset. And you may well have 0 uptime, or you can get an orbit. And that seems to be totally unpredictable. Although I have found it does like it when I don't do anything. You don't command me, I'm fine. But I think that may just be paranoia setting in. So I thought perhaps you might like to think about what is a ground station. That's me in my ground station in one of its early configurations. And as you can see, the FunCube dashboard is very prominent, very essential. This is Chilbolton Observatory. I don't know whether many of you have been to that part of the countryside. It's in Hampshire, deepest Hampshire. It's a 25-metre dish in a field, which is where you should put a radio telescope. The 25-metre dish was used for radio astronomy in its very earliest days. It's now used for cloud physics, and it sort of measures ice and hail and thunderstorms and things like that. And there's a very active cloud physics research group there at Chilbolton. That is not my dish. That is not my antenna. My antenna's that little bit at the back. You know what that is. That's all I need to contact UKube-1. I don't need that. But that S-band dish might be used to test out the S-band from UKube-1. And I like it, the idea of a 25-metre dish to get data from my 30-centimetre satellite. So we've got the UHF uplink and VHF downlink on it. and the actual control room is just here beside it. I could make comments about people who put antennas on roofs of computer buildings, but I won't. I have made those comments to the person responsible. It is a very noisy environment, let's just leave it at that. But this is not just a ground station. You know, we started off once upon a time with the antenna-controlled computer, and then we had the ground station. And so this was actually this is basically what the ground station is. It's just something that points the dish at the right place at the right time and gets the data down. Darcy, the ground station manager, pointed out to me it's just a bent pipe. That's all it's supposed to do. We actually had the mission planning system. This is what Bright Ascension supplied to us to actually generate data. This generates the data that we send up to the satellite with the commands. It also receives the data back down again and stores it in the database. So this can then be extracted and sent off to the payload providers. As I say, we had tremendous trouble with GNU radio getting the actual data down, getting signals down. And this was because it did the Doppler correction okay, but there was something else. Probably thermal, who knows. But this seemed to be fairly random, although I think Alistair and I, we figured out it usually tended to be kind of either positive in the morning and negative in the evening, or vice versa. There did seem to be some sort of trends to it. But it meant that we had no idea what frequency the downlink was going to come in at, and it was going to drift. And GNU radio couldn't cope with it. Now, it copes with interference and noise very well, but it didn't cope with the drifts. And so, you know, it was just a nightmare. And eventually, when we started doing commanding using this system, I kept saying, you know, it's ridiculous. All the amateurs, people like Graham and Jim and Mike and all sorts of other people, they're getting data. You know, why am I not getting data? This is, you know, excuse me, I want the data. And so in the end, Alistair actually went off. We had the FunQ dashboard and we had SDR and Move. We said, well, what is it that the amateurs are using? The amateurs are using SDR and Move. And so we got SDR and Move. And then Peter Mendham up at Bright Ascension also wrote a new little demodulation procedure so that this now actually does what the original GNU radio should have been doing, was that we can actually capture the data on this, centering it up using the beacon, which is why I'm very reluctant to get rid of it, Graham, because I use that to center the frequency I'm going to receive downlink at. And then the data gets fed into the ground station computer and then stored in the database just like it should. And so we have this hybrid system now, which works very well, except you now notice I've got about 3 computers, 4 or 5 screens, and so I need some engineers to help me work all this. And so this is not just a ground station, this is now definitely a mission operations centre, but it is working. And I now have control over the satellite, and depending on what it's up to, I can control it. So what do? I have the mission planning software to create the commands and send them to the satellite. I have the ground station computer in me. It doesn't like black and white, does it? Which we both know when the passes are. And I send up the data, send up commands and get the data. Because of the resets, I can decide whether I want to carry on with the command sequence I'm using or change to something else, which data is most important to download, and then I can process the data and send it out to the payload providers. Also, when we get the updates for the onboard software, I put those up, and if there's something odd going on, I cope with that. Usually by screaming at Steve or Mark, what did you do? What do I do now? So we've got that. One of the things that is causing a little bit of problems now, you might well be noticing this, that after a year, it's not resetting completely cleanly. And I think you may well have noticed that we've got invalid data on the FunCube dashboard, and so I'm having to add in an extra command for me, which is saying make sure you're in nominal communications. And it may well be that when you get to use it, you want to actually make sure it's in redundant communications, and so you get valid data. Now, there has been valid data. It's not all completely up the creek. There is some good stuff. So we've got 6 payloads, and where are we now? I've taken images. We've got the housekeeping data, which I can, and that tells us how much radiation it's got. And it's actually getting about 65 rem a month, I think it is, or something. So it's, I don't know whether that's good, bad, or indifferent. But it also has this image mode of the radiation damage monitor to see how that's built up. And so recently I've taken another image for the end of mission, so they'll be able to see how badly the C3D camera is affected by radiation from a year. The ionospheric experiment TopCat has got data. I'm not sure yet. That data's still got to go off to Tellini to get her to check whether we got any lock on GPS satellites. I don't know, but we certainly got data. And we also got data from the Janus low power mode and MIC. We weren't able to get the high power mode operational, but they've got the diagnostic data from that. And MIC is actually bad news, good news. The people who built MIC, their company got taken over, and the new company is not at all interested in space. So they can't do anything with that now. However, I have a Space Studio Academy school near Banbury who would be very interested in looking at the data. This is outreach. They may get time off for outreach where they wouldn't get it to work on the data themselves. And so this is the avenue I'm exploring at the moment, is to actually do that. And also the actual housekeeping data, I'm hoping I can get them to work with me on that to try and figure out what is going on with these temperatures and drifts and things like that. I'd be very curious to know whether we could find out a way. Now, of course, we've got the other 2. FunCube, you're okay. S-band, I'd love to try it. I'd love to see. We did it in the lab. It works. The S-band patch antenna works. We used it in the lab in the testing. But the question is, our 25-metre dish at Chilbolton has a filter to keep out the amateur S-band. So we've got to remove it. The other thing, these are some of the pictures I've taken with the C3D camera. And what we now know is the DeTumbling works. This is the dark side of UKube-1, pictures of the night sky. And this, I think, may be a little bit of the one of the AMSAT antennas, because it got curled. We had about a 6-month delay after we'd packed up and shipped it down to Surrey, actually. So it's the DeTumbling may be working too well. It may be nicely aligned with the magnetic field, and it may be nicely aligned so it's always pointing at the sky when it comes over Chilbolton. So the answer may well be for the Open University to find another ground station somewhere else, like Australia. We'll have to wait and see. But finally, for the future, we've now 1 year after launch, and I am winding up operations. There's a couple more things I would quite like to do, but never mind. Come on, come back. AMSAT then gets it, and you've got it for at least 2 years. Hopefully there'll be more CubeSats funded by the UK Space Agency after that. And what actually happened was when we were having problems with it, this is the actual flat sat that we used to test things at Chilbolton before launch and after launch for a bit of troubleshooting. But this then went back to Clyde Space, and they're using it for the troubleshooting, trying to check out the resets and things like that. And This is now, I would say, the sort of new idea that there are these centres at Harwell, Edinburgh and Glasgow, and I think they're called nanobeds now rather than flat sats. But you basically unpack your CubeSat into a long row and have the software, and then payload providers can do, as they did at Clyde Space, they can bring their payload along and check it works and check all their power assumptions and data links and everything are all right. And so, you know, you can actually start using this again for outreach, that people could start building payloads that may not actually fly, but could be proved to be compatible with the actual stuff that does go into space. And of course, UKube-1 itself, when I finished with it, I think it then gets its Oscar. And you can have it. Thank you. Thank you very much.
I'm sure there must be some questions out in the audience, and I know they're desperate for their lunch, but I'm sure they'll wait for that. Anybody got any questions, please? Absolute silence. Oh.
Good.
What's the constraint on testing the S-band transmitter? Is it just that your receiver antenna has the filter, or are there concerns on board the spacecraft?
I was very concerned at the beginning because the licensing agreement says that you can only operate it if you can switch it off, which of course I felt, originally I felt I had no control over what was going on. But of course, if it's on, the next reset will switch it off. Now that sounds okay unless the next reset's 80 minutes away and you blasted the universe with S-band transmissions, which is very, very naughty. Then it turns out, and I'm not quite sure where this one did or did not get written into the agreement, they then said, well, actually, you're only allowed to use the S-band over the UK. The license is only actually for the UK, which I thought was a bit unfair not to tell the South Africans that. Although, in fact, the big problem with the resets is that we could not use the S-band the way it should have been used, because the idea was that you would load up a command to switch on the S-band when it was over the dish in South Africa, which was not the way it worked. We came up over South Africa and then over Chilbolton. And so, you know, we couldn't do it that way. Now, we'd very much like to actually do the S-band experiment. And I think now I'm sufficiently relaxed that I can put in either a short time, so it'll only switch on for 2 minutes, or else, you know, sort of just have it over the UK. But it is a case that I think there's a 3.8 metre dish down at Goonhilly that could do it if it was modified, or our 25 metre dish could do it if it was modified. Problem is we've run out of money. You know, we're a year old now, and the money's dried up, and so somebody's going to have to put their hand in the pocket and pay for the sort of changes to be made. But yeah, it would be very, very nice to do that, and I think now I feel I could control it to the level that it's needed. But the S-band transmission has very strict rules about it.
Okay, well, thank you very much.
Question from the internet. What happens after the 2 years that AMSAT has it?
I don't know. I think that, you know, the agreement I heard was that we get it for 1 year, you get it for 2 years, and then that's it. You know, presumably you will have a lot of other FunCubes up there by that time, and you won't need FunCube 2 anymore. I don't know whether you guys are going to stage a coup or something. Probably, yes.
Just what's a rough idea of the bandwidth and the output power on the S-band?
I honestly don't know what the output power and bandwidth on the S-band is. You know, I would have to look it up if I ever had that. One thing I've noticed that with the CubeSats, documentation is very light. I have the essential information, but not all of it. And so I honestly am not sure I ever knew what it was. I think enough was about the...
I think the English term adequate probably sums it up. Any other questions? Thank you, Helen.
Mhm.
Very much.